So what we'll do right now, today we'll focus on Hadoop, okay? Hadoop and
Okay.
Hive. So these two softwares, if you make installation and
Yeah.
MySQL,
Okay.
three. MySQL or Post, okay? Let's do it three at least. So the first of
We are
all,
using IBM DB2.
okay, you're using IBM DB2 is not free, right? It is a paid software.
Yeah, yeah.
See, that approach is same, see, I'll tell you.
Yeah, yeah.
If you learn MySQL or if you learn PostgreSQL
Yeah.
or the coding character, it
Yes.
means if you go for DB2, go for Oracle, all are same. Only
Yeah.
driver connector name will be changing.
Yeah.
Approach is same. Okay. So I
Yeah.
can discuss you about DB2. No problem. We'll
Yeah.
discuss DB2 during the program. Okay.
Mm.
So this is so first of all, we are going to do setup two component. Okay, one more Hadoop and Hive. That is our target. Okay. So generally, to run the Hive services, we required Hadoop cluster because Hive cannot be run without Hadoop. This
Okay.
is the regions we have to set up what Hadoop. So for Hadoop, we require JDK. That is the flow. Now
Yeah.
we have done JDK. We have
Yes.
already node is available here.
Yes.
So this is the how it goes here. Exactly dependency. So if you see in Hadoop architecture, right? What are the Hadoops? Do you know Hadoop architecture? Dhiren?
At a very high level.
Yeah. See, I'll tell you. So any Hadoop has two components. Okay.
Yeah.
The majorly what we say exactly name node and worker node. Okay.
Yeah.
In a very simple terms, I'm explaining you, not in deep dive. Okay. I can save you the nodes for your study. Worker node here. Or this worker node in a Hadoop it is known as data node. Okay.
Yeah.
So if we have like multiple data node, let's say like 2 and 3 data node we have. Okay. And this node is known as name node.
Then.
Name node. And one more node we say secondary name node.
Yeah.
Okay. Or nowadays, basically in Hadoop 3.x and all, this secondary name node becomes here what? Your standby name node. Okay.
Yeah.
A standby, we say name node. Means high availability, right? The idea being what? To achieve the high availability, we require minimum 2 name node. But as we are going to set up on single node clusters, we don't require, okay? Because
Yeah.
we are mainly looking for the Hive architecture.
Yes.
So first of all, so it means Hadoop has some daemons, okay? Hadoop daemons, if you see, one is name node. So what name node does exactly here? Whenever the client is sending any request, okay?
Yeah.
If the client is sending any request here or user, client or user, so they cannot directly communicate to the name node, okay? So whenever we submit any jobs, the jobs goes to the Hadoop client here. Hadoop client, okay, is a library. Hadoop client. These clients will take a request and process to the name node, not the
Okay.
user. Okay, that is the internal flow I'm explaining you. So what happened here? Here we have two files we have in the name node. Okay, generally one file is that fs image file, and one file is known as edit log file. Okay,
Yeah.
this fs image file keeps your basically the file metadata. File
Yeah.
metadata about the blocks of the files, right?
Yeah.
On which node, it has been deployed, and edit logs keeps about your transaction status.
Yeah.
Transaction status. Okay.
Yeah.
So now what happens like here, whenever we submit the first is the name node. So the name node is the main node, right?
Yes.
It is a master node, we can say, okay, which is responsible to assign to manage uh, files metadata into FSMS file and transactions details
Yeah.
history into edit log. Okay, edit log file. So these are the configurations file that we cannot change. Okay, it is like default, right? It will be coming here.
Yeah.
Then we have data node, right? Then what we have data node. So these are the daemons services which will be running in the background. Okay, so data node means where we it compute user data
Yeah.
and store it. Correct. That is the meaning
Yes.
of data node. Whenever we are sending any data, it will not be computing to the name, but it will be computing to the data node here. Then third, we have what? Resource manager. Resource
Manager.
manager. What does it exactly? So the resource manager is also part of your name node only. Okay, resource manager will
Yeah.
be here. Correct.
Yeah.
Master node as a what? Name node we are making. That is our. We cannot keep master node as separate node, name node separate node. We don't follow that architecture. So in the master node only like the name node. So after that we have what? Resource manager. So what happen? This name node will be sending the information to your resource manager. Okay, here resource manager, which will be responsible to manage the resource of the entire cluster. So it means the resource manager has the information which are the nodes are active, which are the nodes are
Yeah.
deactive, how much
Yeah.
resource are available right now. Okay, and based
Yeah.
on the requests, it will be allocate your default resource. Okay, so let me come back to you here. Hadoop installation 3.3.2. This you have already done Hadoop BMA now. Okay, I'm not going to that part here. Yeah, see that resource manager. Can you see here? Name node, data node,
Yes.
correct?
Yeah.
Okay. Then
Yeah.
next that comes for node manager. So every data node will have the node manager. Every data node will have the node manager here. So node manager part of the data node, resource manager part of your name node.
Name node. Yeah.
Okay, you can check here. So in these cases, what happened basically? So whenever the request, right? So resource manager. After that, like we have the app master here. Okay, app master. What it does exactly? Once the resource manager allocate the resource for your job, it will be basically assign this task to the app master. Okay, this app master will be sending these jobs to corresponding data node as okay allocated by your resource manager. So how it does exactly here, how this parallelly works in the Hadoop clusters. So the first of all, it will send the one request to one nearest data node. Let's assume I have a 200 of MB file, correct?
Yeah.
200, let's assume like 500 MB file I have,
Yeah.
okay?
Yeah.
And I am sending to copy request. Copy means write, correct?
Yes.
Right. So what will happen as per the Hadoop block replications? So number of block, right? How
Yeah.
many blocks will be created? First of all, 500 divided by 128 MB, because 128 MB is the block size into the Hadoop we have configured.
Yeah.
So it means 123 300, right? So it means there will be 4 blocks. Agree with me?
Yes.
How many replica? Number of replica. Suppose in the cluster we are making what 3 replica. So what is the total number of block? 12. 4 into 3, right?
Yes.
Is equal to what? 12. So in that case, if you see right now, if it is 12 block, how it processes, right? Let's assume here. So
Yeah.
first of all, for every block, we'll have some of the block ID, right? Internally.
Yeah.
1, 2, this is replica. Then I'm making here, sorry, 1, 2, and 3. Okay. Now I am making again 1, 2, and 3. Again, we'll have what? 3 replica. So first of all, here the confusion, we think all block is traveling at the same rate. No, that is a wrong assumption. Okay. So like that, we'll have like 4th replica also. So 1, 2, and 3. Correct now?
Yeah.
So every, let's say, this is the block number 1, B1. This is the block number 2. This is the block number 3 here. Sorry, it is also B1. Sorry, 1 minute. This is also B1, and this is also B1. This is B2, 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 and B2. You got the point?
Yeah.
This is now B3. So like that, there will be like block. So what happened exactly? So whenever we are sending this request, right, the Hadoop client is going to split your data into the number of block, not the user, not the name node, okay? So there is a class in the Java they have written, okay? I don't want to go those area right now. So what happened in Hadoop client library, okay? There is a class in Java which has been written to split your data into the number of blocks based on Hadoop configuration. So what it will do? The Hadoop clients reads your Hadoop configurations details on your cluster. Hadoop config, right?
Okay.
Hadoop config. From here, it is getting 128 block, right? That is the question here. So
Yeah.
first of all, Hadoop client is reading your Hadoop configurations path on your cluster based on the block size informations. Okay, it is going to split your data into the number of block.
Yeah.
So if I have 500 of MB of data and we have configured 120 MB size of each block into the Hadoop configurations path, it means it will split your files into 4 blocks.
4 blocks. Yeah.
Imagine I have configured 64 MB block size. Okay, so
Yeah.
there is a file name. I'll show you here. Let me back. Okay, Hadoop installations. 1 minute. I'll show you that file. Let me check. Yeah. So there is a file name which is core site.xml. Okay. So we configure resource managers, and then we have what?
Configuration.
Secondary name node, right? Secondary name node, right? Okay. And then we have what? Node manager. These are the 5 daemons we have into the Hadoop. Okay. Now
Yeah.
to configure this file, first files what we configure in cluster setup, that is now my checkpoint. Okay, I'm coming. The first checkpoint is that exactly for us here. You can see checkpoint. We need to set up configure core site.xml. Okay, that is the first files.
Yeah.
After all, just path configurations and all, I'm not doing. That is there, right? I'm assuming like we are done, right? Path configurations and all, JDK and all, right?
Yeah.
Hadoop path. Okay. So the first point, or let me assume here. So the first point we can say here, JDK and Hadoop path setting with reference to document, correct?
Yeah.
Okay, that is the first step. Once we are done, what we have to do, we need to configure the step number 2. What we are going to set up here, set up Hadoop daemons configuration. Okay,
Yeah.
that is our next step here. So this step basically how we are doing here. In this you can see here 2.1 we need to configure what core site.xml is one file. It is defiled. Okay, we can't change the file name and all. Okay.
Okay.
So core site.xml you can see here. Right now what I'm passing, I am passing default file system. So on which port number my file system should be called, okay, is the one. Second is that what is my temporary directory? Suppose if you're loading some data, correct?
Yeah.
Here, if you're loading some data, so what happened? This data will be taken care by the Hadoop client.
Yes.
Now Hadoop client will try to split your files into the number of blocks based on the file configurations in the Hadoop files, and it processes the blocks internally into the temporary directory. So that's why we are configuring a temp directory location here. Okay.
Okay.
So core site.xml is the file which is used to configure your name node. Okay. Configure
Name.
name node. Clear? What is the use of this file? We are configuring name node using what? Core site.xml.
Yes. Yeah.
In this, we are passing 3 details. One is the file. These are copy paste. Okay.
Yeah.
But we have exactly what is there. And then the host, right? What is the host in the group and the server host? All are server group, correct? All are star. Star means any host, any group, correct?
Yeah.
So this name node will be running on any nodes or any configurations as well as any group. We are not restricting right now. Next file we have what? hdfs.xml. This hdfs.xml is used for your data node configuration.
Okay.
Okay. This is used for data node configurations here into the Hadoop. Sorry. Okay. So this is used basically to configure what? Data.
Data nodes.
So in the data node means what we are discussing about the file block, right?
Yes.
Okay. So see that number of replica right now, how much we have? 1, correct? Because it is single node cluster. Correct? It is a
Yes.
single node cluster. So number of, then what is my name node? What is my data node? Okay. So number of replica, why we are keeping 1? Because I am using right now single node cluster. If you're going for multi-node cluster, now number of replica will become what? 3, correct?
Yeah.
Okay. Those details we are mentioning replications factors, name node, data node details into your
HDFS.
HDFS index. Once again. Let me, I'm checking some other details here.
Yeah.
One file. Actually, I wanted to show you that block size because default it will be 128 block right now.
Yeah.
So that I was looking like, do I have any configurations anywhere? That I'm not seeing. Okay. So hdfs.xml we configure data node. Okay. Name node, data node. Next is that exactly we need to configure MapReduce, okay? Because Hadoop works on MapReduce
Yeah.
algorithm internally to compute your data. So you can see right now in this, we done this. After this, we are coming to two more files. One is yarn-site.xml, one is MapReduce-site.xml. Yeah, MapReduce-site.xml, okay? Here. So this file is used to configure your MapReduce details, like computation details, right? AMR. Yes. So in this file, you can see here what resource we are using here. Yarn, correct?
Yeah.
So just now I told, whenever we load the data, the Hadoop client will send the request to the name node. Name node will communicate to the resource manager. So this resource manager, okay, this resource manager, right? It
Hello.
say yet another resource negotiator. Okay, so this is responsible to allocate the resource based on the customer or user request. Resource manager, right? That we are talking here. Yeah. So
And
whenever,
this is present inside the name node, is it? Yeah.
yeah, inside the name node, yes.
Oh.
So what happen, like whenever we are sending any data to the compute or process, right? In that
Yeah.
case, MapReduce will be used. So MapReduce details we are keeping here. To compute the data, we require resource, correct?
Yes.
So that's why this MapReduce is communicating to your SDP site.xml to get the yarn data set. Yarn resource right here. MapReduce data node informations, yarn resource. One more file we use here, yarn-site.xml. Okay, see that? Yarn-site.xml.
Yeah.
Okay. So this yarn-site.xml we are using right now for configuring your resource, right?
Yeah.
Setup yarn. Clear now? Yarn
Yes.
means resource, right? Resource
It's
details.
right. Yeah.
Okay. So in these cases, we are saying now we are doing this yarn-site.xml here. One is mapped, one is DPS, one is core-site.xml. Yarn-site.xml. So in the yarn, you can see what algorithm it is using, MapReduce, right? Yarn node manager, it is saying MapReduce shuffle. So they are using what some class, see, shuffle handler class internally just for MapReduce. So Java underscore home, Hadoop underscore common, Hadoop underscore HDFS, all these parameter, whatever we have configured on my cluster in Hadoop, Hadoop underscore yarn, these are the defined keyword, okay? Yeah,
Yeah.
Dhiren.
Yeah. Yeah.
This is not related to our any application. This is the defined parameter to be passed. So here, basically, in this yarn site.xml, we have to pass our algorithms. Similarly, in MapReduce site.xml, we are saying the resource is what yarn, and see that class path. See, MapReduce.application.class path. If you go back here, all these class paths here, right? Leave and slash. So whatever the path is there, we are passing to this applications here.
Okay.
1, 2, 3, 4. Okay. One more file we configure environment.sh. Let me check where that file is there. Environment. This file, okay. Configure Hadoop environment.sh file.
Okay.
So this file we use to set up your Java path. That's all. Sudo nano Hadoop environment.sh, right?
Yeah.
The fifth file we use here, Hadoop environment.sh, correct?
Yeah.
So this is just JDK path. JDK path configurations. So once we are done here, now we have done right 1 and 2 checkpoint. Then third checkpoint, what you have to do here, the finally we need to format your name node. Okay, format command. Okay, format name node here. So once you can see right now, the last after configurations, I am going to format. Yeah, finally Hadoop start. Yeah, this is the name node, right? Finally format the Hadoop name node, right? System.
Yeah.
Once this is done, then we are good to start your start Hadoop cluster. Hadoop cluster, right? So use again here start. Remember, right? All.sh, right? So this will start your Hadoop cluster, and a Spark also has the same command start all.sh, right?
Correct.
We have seen. So we have to see like a start.sh, which is starting that we can see.
Yeah.
I feel some conflictions will happen. Let's see. So one JDK Hadoop, then setup configuration daemon. Then what in the daemon, whatever we are going to set up, name node, data node, MapReduce, yarn, then Hadoop path, and then finally we have to format the name node, and then we have to start the Hadoop cluster. So this is the 4 point we have to do.
Okay.
Okay, so
Yeah.
in this case, what is this standby name node? The idea behind this exactly nowadays we say this is standby name node means whatever the FSMS has informations that will get copied immediately to this place also.
Okay.
Okay, so in that case, if one node is down, another node will be active immediately. So that's why secondary name node concept has gone almost. Okay, it is a dead node, no use. So what we do to achieve the high availability of the clusters, we make this secondary name node as a standby name node.
Okay.
So it means whatever data we have into the first name node, those data parallelly will be copied to the next name node also. So if in any circumstances, if this node is down, then another node will be active immediately and all the communications will happen to the cluster. So clients will not have any issues.
Okay.
Clear now?
Yeah.
So minimum 2 name node, we can keep 5 name node also, depends on the Hadoop cluster size, how many nodes we are using. But ideally, either you are going for 1 node cluster, 5 node cluster, 20 node cluster. These 5 daemons has to be configured on the size. Okay, so that is the one here, and I can show you right now. 1
So if
minute.
we have 5 name nodes, then what about the secondary node? We will have the same number of secondary nodes, or we'll have only one?
See, I'll tell you. What is my requirement? Let's say my boss will tell Amit, I need 9 node cluster. Okay,
Yeah.
always you go with the odd number, right? 9 node cluster. So in the 9 node cluster, what will my design? I'll say we'll keep 2 name node.
Yeah.
7 will keep what? Data node.
Data nodes.
Clear now? You got the point?
Yes.
But if I have 500 nodes, in that case, I'll say 3 name node, remaining data node. There is no concept of now secondary name node. Secondary name node is outdated after 2.x only.
Okay. So these
Okay.
3 name nodes, whatever is there, that will have the same information, right? I mean, one name node, whatever it has, the same thing will be copied to other,
Same thing.
like a
It will be
replica.
correct internally. They are
Okay.
communicating. They
Okay.
are keeping the file. And they are talking internally, like SSH we have discussed, right?
Yes.
Yeah. That is playing the key role here. So in these cases, that is happening here. So let me show you something I can say here. So you can see here like Hadoop Scheduler, okay? They use all this default internally. Hadoop schedulers, right? See that 1.x, 2.x, right? Capacity schedulers they use. Then they have a FIFO schedulers, fair scheduler, right? So currently we use a fair scheduler. Okay, we don't use the capacity scheduler. So what this scheduler does exactly? If suppose four jobs are running at the same time and one job is completed, that resource can be shared to other jobs. That is the meaning of fierce scheduler here right now.
Okay.
So these are the default. We don't do changes and all from our side. So that is our so current task is that just you have to set up your this Hadoop clusters. Let me explain you again. So now Hadoop installations I'm coming directly. Okay. Now we have
Yeah.
completed all this list before that. So once we download this tar file, we have to extract the tar file.
Yeah.
Then we have to same change mode permissions Hadoop.
Yeah.
Okay, you know already, right? So do
Yes.
mkda Hadoop, right? We will see
Yeah.
Hadoop you know. Now see that we downloaded the tar file online. After
Yes.
downloading the tar file, we are extracting the tar file.
Yeah.
After extracting the tar file, what we are going to do? We need to create some directory and set user and group corresponding. So what are the directory I'm creating? TMP directory, HDFS directory. Inside the HDFS, I have name node. Inside the HDFS, what I have data node.
Okay.
Okay, but all
Yeah.
the locations is what Hadoop right now, correct?
Yes.
Hadoop. So now we have this directory. So mkdir temp. Once we are done, then we are setting the permission of the directory 7777.
Yeah.
Okay.
1 minute,
Then
Amit. Now this Hadoop directory, like, see, my case, we have already created a Hadoop directory. So should I create a new one like Hadoop one, or because
no,
everything
no,
now I am placing in
can
Hadoop.
everything in Hadoop only, no problem. No need to change it.
Okay.
See, I already am assuming right now we have already Hadoop directory, correct? See
Correct.
that
Yes.
what I'm doing inside this Hadoop only I'm making tar
Yes.
xzvf this
Okay.
places.
Because inside the Hadoop only I've placed Scala and all those. In the same place, I'll continue it, right?
All the softwares here, a Spark, a Scala, Kafka, IntelliJ, Hadoop, MySQL, whatever software we are going to install, and even projectation, everything is a part for us. It is a Hadoop location, common global location, correct?
Oh, okay. Got it. Yeah.
Okay.
Yeah.
Or otherwise, what will happen? See, I'll tell you. Suppose if I change the path, we can change the path. I'm not denying. But tomorrow, suppose if you have to debug your Kafka some information, then you have to search the Kafka path. If you change for the Hadoop path, then a Spark path, a Scala path, rather than we know all the software you want to Hadoop, right? Directly you can go to the Hadoop and you can see the path, right? Immediately.
Yeah.
Okay. For that purpose. Otherwise, you can keep a different directory. That's not a problem.
Got it. Yeah.
Okay, so here, but in this, for related to the Hadoop, we have to create some of the directory like TMP directory, HDFS directory. Inside the HDFS, we are making what name node. Inside the HDFS, we are making a data node. Correct. So all
Yes.
this directory, because see whatever we are saying here, name node, data node, all are what is a directory. What is the name node? Name node is storing your FS image file and edit log file. Correct.
Yes.
What is data node? It is loading your data. Okay.
Yeah.
So that's why only name node and data node, we have to create a directory, this name node and data node, not resource manager SSN and all, okay? Only for these two directory. So these two directory we are saying is a part of what your data node right here.
Yes.
Clear now?
Yes.
Okay. So in this case, you can see right now what we are doing here. I am creating one HDFS. So if you see here, this data, what is this data node? Data node, finally, we can see it is nothing but your what? HDFS only, right? All this
Yes.
data node is what? HDFS.
Yes.
Because we have to load the data to the corresponding data node, correct?
Yes.
So finally, this data node are nothing but what? Hadoop distributed file system.
System.
Because
Yes.
whenever you are loading the data, it is going to load the data to the corresponding data node
Yeah.
as a HDFS file, correct?
Yes.
Now, uh, this is clear, right? So all this temp, right?
Yeah.
HDFS and all, we are setting the right. Then we are setting the permission right here.
Yes.
After this permission setting, what we are going to do, these are the same permissions and all. We have already seen the previous configurations.
Yes.
Okay.
Yeah.
Let me come back. to the another locations here. So Hadoop 3.3.2, okay.
Yeah.
Inside this, you can see I am coming etc in Hadoop folder, right?
Hmm.
3.3.2 etc Hadoop folder.
Yes.
I think I don't have the Hadoop cluster right now available with me.
Oh.
Let me check something I can get Hadoop anywhere. Okay. Meanwhile, let it be. So inside this etc Hadoop folder, we are seeing so many files, correct? See that all are XML, correct?
Yes.
See Hadoop environment.sh, HDFS site.xml,
Yeah.
core site.xml, fourth file. So all the configurations file, whatever I am explaining here, right? 1, 2, 3, 4, 5 files.
Yeah.
This file is inside your etc Hadoop.
etc. Yeah.
Okay. The file location for all this file, whatever we are going to configure here, from here to here, right? All this file is a part of Hadoop etc Hadoop. Okay.
Yeah.
This is inside Hadoop 3.2.2/etc/Hadoop. Clear now?
Yes.
Okay. So
Yes.
we have to come to this place and we have to do the changes based on using the nano editor, right? So that's why you can see right now, this is all file. I'm trying to show you highlighting here. So configure JTK path to Hadoop environment.sh, correct? So what you have to do? Sudo nano Hadoop environment.sh, right?
Yeah.
Okay.
Yes.
So now you know, right? So that's why I'm not going too much
Yeah.
slow.
Yeah. Yeah. I'm understanding.
So export Java underscore home. Only this line we have to copy paste it, and that's all, and we have to exit it. Okay. Control X and Y key, right? Y and
Yes.
enter. Similarly, bash RC, right?
Measures. Okay.
In the bash RC, we have to set the Hadoop path.
Hadoop path. Yeah. Got it.
So this is just all copy paste. All copy paste. So Hadoop home path, right? Then Hadoop map reduce, Hadoop common home, Hadoop HDFS home. This is the common, right? All. So this is just copy paste for you.
Okay.
Okay. So once this path setting is done, then again source command,
Source
then we are
command.
good. Okay, the path configuration for Hadoop is completed.
Okay.
After that, what I am going to do? Configure name node using core site.xml, correct?
Yes. Individual. Yeah.
Okay. So now I have to open to this core site.xml here. Let me show if something is there. This will be entire copy paste. Nothing
Yeah.
you have to do.
Yeah.
No typing. Okay.
Yeah.
Don't do one type. This will be blank file. Okay.
Yeah.
So it will be like this configurations and configuration. Inside this configuration, we have to copy from property to property type from here till here and paste it into the XML file.
Got it. Yeah.
Let me check. I think it should be here. Okay. And then similarly for HDFS.xml also, nothing you have to do because we know the path is same, right? User local Hadoop, right? HDFS name node, user local Hadoop, HDFS data node, correct? Our path is same. You
Yes.
machine my same.
Yeah.
That's why just you have to copy paste.
Okay.
And then if you're coming to the answer documents, again, this is the copy paste. Now, comping this part, right? Be careful.
Okay.
Sometimes what happen, it will just paste it only this much.
Okay.
Next one. So that you can see exactly, okay, carefully.
Yeah.
All this must be available here, okay? Make
Yeah.
sure.
Yeah. Yeah.
And then similarly for what we are going map reduce. So this is also in copy paste. No need to type and all, okay, here. Okay.
Yes.
So once this is done, name node format, we have to run the
Um,
command hdfs name node hyphen format is the syntax. So format, what is the meaning of format?
update the changes.
No, not format. Format means clean up, right? Format command. Like
Yeah.
C drive, if I need to format, I lose all the data, right?
Yes.
The format means you're removing all these existing informations from that directory, name node directory. See, we have created two directories, name node and data node, right?
Yes.
So suppose I created some directory. So I want to format before starting my Hadoop. Means the directory should not have any informations
Yeah.
before start. First time I start, I'm saying.
Got it.
Clear enough? So for
Yes.
that purpose, we must format Hadoop name node command. Let me check. I have a Hadoop or not.
And when we're creating the directory, I mean, it's an empty thing only, right, Amit?
Yeah, it's empty. Also, I have old one Hadoop, okay, 2.7. So if you go here, cd etc and Hadoop right now, if you're coming here right now, you can see, right? Code site.xml, hdps.xml,
Yeah.
map reduce environment.sh, environment.sh, right? Hadoop environment.sh. Depends what is my requirement. Map
Yeah.
site.xml, yarn site.xml, all this file here. So it is 2.7, it may be 3.2, no matter. The file is same, okay?
Got it. Yeah.
So suppose I want to go to sudo nano hdfs hyphen site dot xml, correct?
Yeah.
Open. I should not given sudo, right? See, it is just copy paste, right? Nothing I have to do. So what I'm saying, initially might be this file is not available, okay? So just we have to, this will be blank file basically here.
Got
So
it.
from here to here, we have to copy paste from there.
Yeah.
Suppose if you're going for nano core site.xml, okay? If you come here, just you have to copy paste from here. See that?
Yeah.
This is the PMP. This is the BLC Hadoop.host. This is the group level informations. Okay, that's all right. So these are the defined syntax. Okay, so as an admin, they work. That is not our work basically. That's why we sudo nano yarn, right? I was saying you yarn
Yeah.
site.xml. See, only I've given the map reduce also. So in this case, this is the way how we configure this path. Okay, once we have configured this path, okay, and we have formatted this Hadoop name node and all. Let me see, do I have a Hadoop or not here? So start hyphen all dot sh, right?
Yeah.
Let's see what is starting. So once we are done with the Hadoop, then we have to go for hype setup. It's taking time. It should not take. Yeah, see that? It is starting on name node, right?
Yes.
Then it is starting data node.
Yeah.
Okay. So first daemon, second daemon, then what? Second in daemon, right? Third daemons. So see that it is not asking the password now. Correct? Why it is not asking the password? Because SSH is configured.
Yeah. Got
Otherwise,
it. Yeah.
it will ask the password for name node, for data node, for secondary name node, for resource manager, right? See, starting node manager, right? So node manager, resource manager, name node, data node, okay, secondary name node. So if you give a command JPS, let's see what happened. So we got secondary name node, resource manager, node manager, data node, name node.
Yeah.
Okay. So we got
Yes.
everything. So now if you go here Hadoop fs-ls and the root point. Okay, let's check. All this directory I have. If I format the name node, what will happen? Tell me now. Now if I run the Hadoop format command on my node, what will happen? It will remove all this HDFS, right? It will clean up, right? Why? Because we lose the metadata. You got the point? That's
Yes.
why Hadoop name node format command is recommended only the one-time activity when we
One time.
complete installation, not after that.
Yeah.
Okay. So now let me go to cd user local Hadoop HDFS, right?
Yeah.
Let's see. Now we have a name node. Let's see
Yes.
here. See, I have a current directory here. Then let's see here. See, what is this?
FS
FS.
image.
And what is this?
Edit
Edit
logs.
in progress, right? Means current file,
Yeah.
right? When we run the services, correct?
Yeah.
You got the point. So this
Yeah.
FS image file which keeps your metadata block informations, okay, and this is the file where we have the transaction detail, right? That's why it is saying in progress, right?
In progress. Yeah.
Because now Hadoop is running, that's why it is coming in progress here. But if you open
Yeah.
here, cat edit, can you see something like that? Let me check. 0007615 907. Okay, this file I'm talking.
Yeah.
This file. Okay. So let's see. What is see? Can you see? We can't see, right?
Yeah.
Okay. So these are the hidden files now. We cannot read, right, inside this. Similarly, if I go here right now, cat fs image, right? 000, and let's say I want 8494, right? Let's
Yeah.
see what is it here. We can read something, okay? Some details we can read here. See, time as time, date, right?
Yeah.
See, shopping delete.txt file, shopping delete.txt file, hyderabad.txt file, right?
Correct.
See,
Yeah.
13th May 2017, right? This was what? 13th May 2020. Can you see now?
Yeah.
So this is Hyderabad, right? City is equal to Hyderabad. Whatever query we are doing, right? And whatever data we are loading to the Hive. City is equal to Hyderabad means Hive, right?
Yes.
So those details also coming to Hadoop clusters only internally here. So this is what succeed details here, right? Success is default, or if it is fail, all this we have the same, right?
Yeah.
Metadata about the file, right? Where it is loaded, right? On which node. So that is the points here. What we are talking about: edit log file and FSMS file. You got it now?
Yes.
Okay. So
Yeah.
that's why we are not supposed to touch here. Now let's go to data node. Okay, we will come to know data node. Now I'll go to current. Okay. Then again I'll go to the current here. Again I'll come here. See, all these created by the Hadoop only, right? We are not creating, right? All this file, right?
Yes.
See, subdirectory 0, right? So like that, it's store your data to this location. That, but we don't go these places and all because we cannot read any information. We don't know exactly. The only name node knows all this about the files details, right? Structures and all. Okay. So that's why we are keeping configurations name node and data node on the nodes. And this is the Java command, okay, which are the services right now is running on the Linux machine, not only the Hadoop. Suppose I'm running Oracle, I'm running MySQL, right? or I'm running some another servers and all those servers, whichever is running right now, we can see. And these are the port number. On which port number, basically it is working, running.
Yeah.
So this is all about the Hadoop path configuration. You can do it. If you have any problem, let me know. We can discuss.
Yeah.
Okay? Next, I'm coming to